So far, our Flask apps have only been serving HTML pages, but Flask can do a lot more. It can also serve data, and that's where APIs come in. APIs let your app communicate with other applications, or power a frontend built with JavaScript that fetches data directly from your server. If you want to explore some cool examples, check out this list of public APIs. Today we're going to build a basic REST API. We'll break down what RESTful actually means. Spoiler, it's not about lying in bed on a Sunday morning. Learn how to return JSON responses instead of HTML, and even test our endpoints right in the browser using fetch. REST stands for Representational State Transfer. Don't let this name scare you. It basically means your server provides resources, usually in JSON format, and the client decides how to use or display them. And honestly, I've been building stuff for years and I've never really sat down to read the fancy academic definition either. My first thought, okay, is resting return JSON data, cool. In practice, that means instead of sending HTML back, your Flask route can return data like this. That JSON response can then be used by a front-end app, some JavaScript running in a browser, or even another backend service. Flask makes returning JSON super easy with the JSONify function, for example. You can also return status code. For instance, a 200 means success, a 404 means resource not found, and a 500 means something went wrong. In Flask, that looks like. With this, your routes become clean, predictable APIs. Let's build a simple API endpoint. Say we want to serve a list of users. If you visit API users, Flask returns JSON instead of a web page. Now let's imagine you have a JavaScript frontend. From the browser, you can grab that data with the fetch API, for example. The console will print out our user list. That's how frontends talk to backends in the modern web. Right now, our API users route returns all users, but in most APIs, you can also fetch a single resource, for example, one user by ID. Now visiting API users 1 returns only Alice. If you try API users 99, you'll get a 404 not found because that user doesn't exist. This pattern using -id in your routes is how most REST APIs handle individual items. Let's take it one step further. Instead of the ID, what if we want to search by name? Flask lets us grab query parameters easily. Now you can visit this route and get Bob's data. This mimics how real APIs let clients send filters or search queries, and it's often cleaner than creating new routes for every case. Most APIs don't just read data, they also create it. To accept new data, we can use a post request. Then from JavaScript, boom, you just added a user via API. This opens the door to CRUD, create, read, update, delete operations, the foundation of most web apps today. So today we explored what REST APIs are, returned JSON and status code with Flask, built endpoints for all users and single users, and even added search and post requests. That's a full mini API in just a few minutes. We've learned how to read and add data, but the full API usually supports all 4 CRUD operations. Put is used when you want to update an existing resource, for example, changing a user's name. Delete, as the name suggests, removes it entirely. In Flask, they'd look something like this. These are your challenge. Try implementing them using what you've learned so far. Hint, use the same user list, find the user by ID, and return a message confirming the update or deletion. Next time, we'll look at error handling in Flask so our apps can fail gracefully instead of exploding in our faces. Like that time I put an egg into the microwave. Trust me, don't try this at home. I'll see you in the next dimension.